Okay, let's review for our first exam. So just to remind you, for true and false question, provide your reasoning. Okay, if the answer was false. For multiple choice, also you need to show reasoning or calculation. All right, so be careful with those two. Let's see true or false question. So for the first one, the key point is we need to know time series data, right? And also we need to know cross-sectional data, right? So when we're collecting data, we're collecting those two types. Cross-sectional means at the same point of time, at the same time. Time could be one semester, the same semester, or the same year, the same month, the same day, the same week, right? So at the same period of time. That's cross-sectional, right? You collect different categories. You collect data from different categories. Time series data involves time. So it's a chronological data, right? From first grade, second grade, third grade, right? Time. So this is like your grades, think about the grades from first grade, second grade, like so on and so forth. So time is changing. It's chronological. So second one, the mathematical operation of addition can be performed with nominal data. Right? Remember, we have four types of measurement scales. Right? Nominal is the lowest one. Nominal data, you can only give a name, or you can give a label. You can label it, or you can code, right? Nominal data, like a phone number, like a zip code, like a hotel number, university number, right? Nominal. So of course, we cannot, do addition. Nominal data are categorical data or qualitative data can be described, right? Use language or use numbers to code nominal. So this, you need also, you need no nominal. The second one is ordinal, right? Which now you can put in order, maybe like ranks. Each restaurant has ranks from A to B to C to D, right? So each restaurants with names, now they're having ranks. So ranks has orders. A is better than B, B is better than C, C is better than D. So this is ordinal data, right? With a name, with a label, with a code, but also with order. So both of these are qualitative data or categorical data. We cannot perform addition. Then we have interval. We have interval, right? Numerical. With the highest one is ratio, right? So those two are numerical data or quantitative data, right? Interval, in the interval, right? But in this case, it says the definition says zero doesn't have a true meaning. Zero doesn't have true meaning. A ratio, right? Ratio means we can do division. And also zero has a true meaning. So ratio we can do. So in the interval, we can do plus, we can do minus, but the only thing is zero doesn't really mean anything. In the ratio, we can do plus, we can do minus, we can do multiplication, we can do division. Right, so ratio measurement has the highest measurement. Okay, so 3 testing about the scatter plot. Scatter plot, remember the graph with data points, two-dimensional, right? This data has two-dimensional values, has one value for horizontal axis, another data for vertical axis. So we need to know how to make a scatter plot and how to read a scatter plot, right? And then if a scatter plot is like all over, right? We see there's no obvious relationship. Scatter plot measures the relationship between two variables. So this is in a scatter plot is a graphical tool that helps determine whether or not two quantitative variables are related. Yes. Right. Yes. If scatter plot gives like this way, we see positive linear, right? Or if we see a little bit of curvy, right? Could be linear or could be non-linear, but the relationship is positive, right? Positive relationship, which means the x value grows bigger, y value grows bigger. So those two go hand in hand, so positive relationship. Or if we have another one, let's say we have something like this, right? So this will be negative relationship, negative linear, or if I draw a little bit like this, right, non-linear. Okay, so for in the data set, outlier. Outlier is an extreme value in the data set. Extreme value in the data set. Let's see if we have a student age. Think about it in Pace University, right? Normally you see people around from 17, maybe up to 25. Then all of a sudden you see someone 50 years old as a student, right? The 50 years old would be outlier. Or maybe some kids are truly smart, right? So basically outlier is far away from the center of the data set. It's extreme value. Number 5, standard deviation is a positive square root of the variance, which is true, right? So for those, we also need to know some more concepts. So I will make some list on here. So let me just delete this. We need to know, of course, two data types, right? One qualitative, one quantitative, or one categorical, one numerical. And then we need to know we have time series data and cross-sectional. We need to know the full measurement of data. We need to know how to read and plot, scatter plot. We need to understand some terms like outlier and also remember statistic or maybe statistics. Statistics is a value from a sample. And another word is a parameter. Parameter is a value from the population. So we need to know this. And then we need to know how to measure the center, the median, mean. We need to know how to calculate them, how to find them, mode. And of course, we need to know how to calculate the variance and standard deviation. Okay. So okay, let's see multiple choice. Multiple choice questions. The first one, we need to know population and the sample. So sample is a subset of population. Right? Basically, sample has to be part of the population. So population is the whole thing, and sample is part of it, part of the population. So if we check A, B, C, D, only A, right? Residents of Albany, New York, registered voters in Albany, New York. So only A satisfies, only A is satisfied. The sample is a subset of the population. So number 7 is asking analysts collect data, closing price, all right? Closing price we can divide, right? Maybe one day is 25, the other day is $10. We could see, okay, it's 2.5 times more. So can do division. So ratio scale. Number A could ask, different questions, right? The numbers could be changed, and this is higher than 3, or maybe between two numbers, or maybe less than a number. So we just need to count how many. So in total, that's 30 data, right? So the data set equals to 30. All we need to find out is the subset, whichever satisfy, how many satisfy this. Well, this could be changed, right? Higher than 3, so which is 4 and 5. Just calculate 4 and 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 15. So which is 15 out of 30, which is half, which is 50%, which is C, right? Well, 9 is a scatter plot. We see this, okay, let's see because, well, we could draw here. I was a little bit off. Could draw a line of best fit somewhere. Right? It's like a positive linear relationship. The first one, no relationship, no. Negative linear relationship, no. Negative goes this way. Negative curlinear, no. So has to be D. A positive linear or curvilinear relationship. Curvy means a little bit curvy. So it's the last one. And when do we see there's no relationship? When it's all over, right? We cannot use a mathematical function to describe it like this. We will see, okay, no relationship. So this one, so 50 selected stacks. So which means total is 50. So let's count A plus 2, 10, 35 plus 15, 40. Yes, 15 total. So number of stacks with return of less than 10%. Less than 10% is those two categories, right? Negative 10 up to 0, 0 up to 10, less than 10, so including those two categories. So A plus 25, 33. The number of stacks, okay, the number of stacks is 33, right? Just count. It's not asking property or percentages. So C, answer C. Okay, 11. So I given some sample of stacks. We're given 1, 2, 3, 4, 5. 5 data. And we know this is from sample. So we need to calculate the standard deviation. So first we need to calculate the mean. Mean means we add them up. We divide it by 5. Right, so 1, 2, 3, 4, 5. So that would be the mean value. Then we subtract every number from the mean number. So we do 4.2, subtract the mean. Then square this difference. We do for each one. Negative 9.4, subtract mean. And remember the mean is negative 5. Right? Minus negative 5 become plus 5. Square. 4.2 minus negative 5 become plus 5 square. So we need to calculate it for all of them. Then we add them. We add all the squares. Then we divide by 4, right? Because it's 5 minus 1. Because it's 1, 2, 3, 4, 5. I have 5 of them. And we know this is sample. From a sample, so we divide by 4. Then we square root. And remember the answer is 8.49. Right. And related to this, that's variance, right? If we do not square root, that's variance. And if you could, remember standard deviation for sample, use S. Right? S squared will be variance. And for population would be sigma. So 12 is asking, mode is defined as the middle point, where the middle point is median. Geometric average of data set, that's geometric mean. Arithmetic average, that's mean. Right? So this one is a geometric mean. D, most frequent value in the data set. Yes, D. We're given this table, right? We're given this table. So, couple questions being asked. 13 is asking, identify the two variables with ratio scale of measurement, well, that only can be price and assessment. That this is with money. With money, we can calculate them. We can add them, we can subtract them. In this case, we also can do division, right? So ratio 500,000 is doubles 250. We don't have 250 here. And right, so identify two variables with ratio scale, that would be price and assessment. Would be this one, would be price and assessment. Right, these two has a ratio scale. Is class a qualitative or quantitative variable? Well, class has residential or commercial. Either residential or commercial. Right, those are names. Those are only names, nominal data. And yeah, qualitative, qualitative variable, nominal data set. 15 lists all categories in the town variable. So we have Avalon. So in the town variable, we have Avalon, we have Wildwood, we have North Wildwood. So 3 of them. 16, build a frequency distribution table for assessment variable, right? For assessment, so build a frequency distribution. Remember, tables start with a title, right? Maybe see, because this is property, right? Property sales assessment. Right? Just give a name. Property assessment. So we need 2 columns. This would be assessment price, assessment. Right? You could do it in thousands. You don't have to write the 3 zeros. Then this is a frequency. Okay. So how do we do this? First, we find the biggest number, which is 6077. So ignore the hundreds, right? Think about 607. Or maybe carry on the 7, think about 608. The smallest number is 250. 250. Well, maybe think 610 minus 250. Well, that's what is that? 600 minus 250, that's 350. So plus 10, 360. 360, maybe we think to make 6 classes. So then the difference would be 60. Right? As long as your class intervals are reasonable. Right? So the first class will start with the 250, then up to, so because we want to do 60, so the next one will be 310. So this will be 309. Right? Then keep adding 60, 369, 370, then the 4 plus 60, 429, plus 60, 430, plus 60, 489, plus 60, 490, plus 60, 560, 49. So 1, 2, 3, 4, 5, 6. Then plus 60, 550, up to the highest one. We can include in the last one in the highest one. Because if we add 60, that's 609. Then we just add more, a little more, 610. So we can include it. Well, we could actually do 609. 609, including that one. So 609 is fine. And then lastly, we total. Once we have these classes done, we just go back to count how many prices in the range of 250 to 309. 250 to 309. 1, 2, 3. So 310 to 369. 1, 2, 1, 2. Okay. 370 to 429. 370, 1, 2, 3, 4. Right? 370 to 429, we have 4. 430 to 489, none, 0. 490 to 0. 550 to 609, just this one, just one. So how many we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So total should be 10. Now let's add up. 3 plus 2, 5, plus 4, 9, plus 1, bingo, 10. Okay, so this would be one distribution table. I remember I did in class, I did five classes, right? With 70 lengths to be 70. All right, so 5 or 6, it's fine. So 17 asks to construct a histogram for price. Again, we start with the title, right? Start with the title. We see property price. Right? Maybe everything we do in $1,000 as units. So price actually is a very close. So from 500 up to 525. So let's say this is 500. 525. Maybe we go with 5 as 1 unit, right? So 505, 510, 515, 520, 525. Then the frequency, let's see, 1, 2, 3, 4, 5, right? 5 is a higher frequency. 3, 4, 5. So 5, 3, 1. So we have 1, 2, 3, 4, 5. 5 in 500 range. So we just do a rectangle. Make a rectangle, right? So that's 5. Then the next one, so 518. So from 505 to 510, none. And 518 is in the range, so this is also none. From 515 to 520. 520, so we have 1, 2, 3. So we have 3 here. This also depends on, so in my head, I have built a distribution table actually. So depends on that, depends on how I make this. Then 520 to 525. So 520 to 525, so that's 2. Remember the lower end is not included, only the higher end. So 525, 525, how many? I have 2. So I have to do maybe 530. So 2 of them, 2 is here. So yours doesn't have to be exactly like mine, but as long as it's reasonable, all right? This kind of question is not very, very good. All right, then 18, find the percentage of cells that were below 300,000. Below 300,000. Right? So there has to be an assessment. So less than 300,000. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So total we have 10. Below 300, so 1, 2, 3, 3. So 3 out of 10, which is 30%. Right, so the percentage for the cells for the assessment below 300,000, 3 out of 10, or 30%. Okay, then this question wants us to calculate the sample variance and the sample standard deviation. Yeah, we have 2. We have a gold ETF, we have a silver ETF. So this is for different time. Right. This is January 8th. So now we know this data. What kind of data is this? Time series data. Right? Time series data. So the vertically is time series data. Horizontally is cross-sectional. You see, if I can only talk about this one, right? Cross-sectional, I have X, I have a gold ETF price, I have a silver price. So this is cross-sectional. But vertically, so this X data is time series. Okay, anyway, so we're given gold price 1, 2, 3, 4 for data. We have calculated mean value to be this. Silver for these 4 days at these prices. And also the mean is being calculated. So we need to, and we know this just some samples, right? Sample, the sample variance, sample standard deviation. So which means we need to do, so this mean is given, and even this data minus mean value square given. So all we have to do is just add them up. So we add this up, so we get this number. And then we use this number divided by, because we have 4, 4 minus 1 divided by 3, that would be the variance. Then we square root to get S. Right? So same thing for this one, for the silver. Once we have calculated that, we can answer 20 and 21. Right? 20 is in which asset had a greater variance. Right? You just use this number to tell why, right? Which one is greater. Which one has greater relative dispersion? Which relative dispersion means a standard deviation, bigger standard deviation. You use a number to speak for you. Lastly, we want to draw a scatter plot, right? To check the two funds, check the gold price and silver price, how they related. So here we see we have points. We have 83, 15. This is 1 point. So let's just graph scatter plot. The x value goes from 83 up to 139. So maybe we start with 80. 80, because of 140, right? 140, 140. Right, we could go 90, 100, 110, 120, 130, 140. Right, so those will be our x. And for silver, 15, 11, so 11 up to 30. Maybe we'll do 10. Right, let's see, this is 10. This is 20. This is 30. So 83, 15. 83 somewhere here. And the 15 right in the middle. So we have this point. Then 87, 11. 87 close to 90, 11. I have this point. Then 110, 17. 110 is here. 17, it's here. Then 139 and 30. 139 and 30. Somewhere here. Okay. So I have these points. We have this one, this one, this one, this one. We could see, right, this we could have, this is a positive linear relationship. Right, positive linear relationship. Okay, that's it for the fourth exam review.